Dual nature of radiation. Today we shall discuss de Broglie waves. Now here it is clearly can be seen that the light, some of these discussions such as interference, diffraction as well as polarization, all other such things can be explained on the basis of wave nature. However, at the same time, phenomena like photoelectric effect, Compton effect, etc. can only be explained through quantum theory of light, right? So this explains that radiation has dual nature, right? Sometimes it may behave like a wave and some other times it behaves like a particle. So let us now discuss de Broglie waves. As we know, Einstein's mass energy relationship gives you E is equal to mc square, right? So de Broglie suggested that as radiation has dual nature, matter must also possess dual nature, right? So particles like electrons, protons, etc. should not only behave like mass, but they should also exhibit wave nature in motion. So to understand de Broglie's wave equation, we have to go to Planck's theory that if a photon has the frequency nu and the energy associated with such a photon would be given by E equal to h nu, and nu क्या है? Nu है frequency of the photon and h is the Planck's constant. So Einstein's relationship is also given by E is equal to mc square. If we equate equation 1 and 2, what shall we get? We shall get h dot nu equal to mc square. Okay, so but nu क्या है? Nu is the frequency which is equal to c by lambda. So we can replace, instead of nu we can write c by lambda. So hc by lambda equal to mc square, which means lambda is equal to hc upon mc square. Now let us understand what is the value of lambda. Lambda is equal to h upon mc, which can be written as h upon p. Now lambda is the wavelength of the radiation of the frequency nu. So through this discussion, what are the main findings of de Broglie's equation? The finding 1 is the wavelength of a moving particle is inversely proportional to its momentum, that is lambda is proportional to 1 upon p. Second point of de Broglie is if frequency is equal to 0, that means lambda would be infinity or infinite. It implies that waves are associated with material particles only when they are in motion. And the third point is, to be associated with de Broglie wave, a particle need not have a charge. As a result, de Broglie waves are known as matter waves. De Broglie waves cannot be associated or cannot be electromagnetic in nature, because electromagnetic waves are associated with accelerated charged particles. Okay, so these are the 4 major points associated with de Broglie wave equation. Now, how to find de Broglie wavelength of an electron? मान लेते हैं कि एक इलेक्ट्रॉन का मास m है and it has attained a maximum velocity v when it is accelerated through a potential difference of capital V volts. So what is the energy that is gained by the electron? It will be half mv square. So we can say that the kinetic energy K is equal to 1 upon 2m into m square v square. M square v square can be written as p square. So K is equal to p square upon 2m, and work done on the electron is E dot V, where V is the voltage applied. So p square upon 2m can be written as E dot V. Also we can write p square as 2mk. So p equal to under root 2mk, where k is the kinetic energy, and p is equal to under root 2 mev, where E is the charge of an electron and V is the potential difference through which electron is accelerated. So hopefully you must have understood about de Broglie waves. Now let us understand the key takeaways from this discussion. One is, which we have learnt, number one, the momentum P is equal to under root 2m k, where k is the kinetic energy. We can also say that lambda is equal to h upon p, or we can say h upon mv. The third point is, de Broglie wavelength lambda of an electron is given by h upon 2m e k under root. Also it can be written as 1.23 upon under root v nanometer. Okay, so also we can also understand what is the Bragg's equation. Bragg's equation, it is the equation for crystal diffraction, for crystal diffraction, and it is given as 2d sine theta equal to n lambda, where n is the order of spectrum. N is the order of spectrum. Let us understand this through one illustration. Let us write what is the de Broglie's wavelength associated with an electron. Associated with an electron, accelerated through the potential difference, accelerated through a potential difference V volts. Let us understand the application. De Broglie wavelength formula lambda was given as 1.23 upon under root V nanometer. So let us apply the formula. We can write under root 100. So we will get 0.123 nanometer. So that will be de Broglie wavelength. Also we can have just one another application question. The kinetic energy of electron, the Ke of electron orbiting in the first excited state, orbiting in the first excited state of hydrogen of atom is 3.4 electron volt. Determine the de Broglie wavelength. Determine the de Broglie wavelength associated with it. Associated with it. तो कैसे आंसर करें इसको? Let us try to answer. What are the details? K is equal to 3.4 electron volt. तो इसको जूल में कन्वर्ट करो by multiplying 1.6 into 10 to the power minus 19. So we have got answer in joule. Now let us apply lambda is equal to h upon mv, which is nothing but h upon under root 2mk. So what shall we get? We will get 6.63 into 10 to the power negative 34, that is Planck constant, upon under root क्या क्या आएगा? Twice times m is 9.1 into 10 to the power minus 31 into kinetic energy we have already achieved as 3.4 into 1.6 into 10 to the power minus 19. So my lambda would be 6.63 into 10 to the power minus 10 meter. I hope this topic is well understood now. Let us meet with a new video in the next session. Thank you so much.